And welcome Geometry to Chapter 8, Section 5, Law of Sines and Law of Cosines. So pause, make sure you're thorough, come back and check your work. And number one, the third angle, 72 degrees. And rounding to the nearest degree. And the nearest hundredth, we have, in this case, 96 hundredths, 95 hundredths, number 4 is 7, and 12 hundredths. And the degree, 20 degrees, 51 degrees, 70 degrees. Today the objective is to use the law of sines and the law of cosines to solve triangle. So in today's lesson you will learn to solve any triangle. Previously we've solved right triangles using our ratios, our trigonometric ratios, right? Now we can solve any triangle when we learn the law of sines and the law of cosines. So to do so, you will need to calculate trigonometric ratios for angles up to 180 degrees. You can use a calculator to find these values. Also, I have a table for you. If I haven't given it to you already, you can ask me for that table. So you could use a table rather than a calculator if ever you needed to. So let's try this. Use your calculator to find each trigonometric ratio. Round it to the nearest hundredth. So keep in mind, in a right triangle, we would never have an angle of 103 degrees, right? But in a obtuse triangle, we might. So the tangent of 103, again, come back and check when you're ready, is negative 4 and 33 hundredths. And the cosine of 165, negative 97 hundredths. And the sine of 93 degree angle is 1. Rounded to the hundredths. Isn't that interesting? When you look at the hundredths place, it's 9.998. And so 9 would round up to 10, which rounds the 9 here up to 10, and the whole entire sine of 93 degrees rounds to 1.00. Notice that we see the hundredths place. That shows that we rounded to the nearest hundredth. All right, this is super important. This is the reasoning behind the law of sines relationship. So before we look at that rule, let's look at this triangle. You can use the altitude of a triangle to find a relationship between the triangle's side lengths. In this triangle ABC, let H represent the length of the altitude from vertex C to side AB. Now, from the diagram, we can see that sine of A, remember sine, that relationship is opposite over hypotenuse, right? Opposite over hypotenuse. So this is this little triangle we're looking at. Sine of A would be H over the hypotenuse B. Sine of B would be H over the hypotenuse A. So we can solve both of these equations, right, for H. So to solve the first for H, we simply multiply both sides by B, right? And when we do, we get sine of A times B equals H. H equals B times sine A, okay? Second one, we can multiply both sides of this ratio by A, right? And we end up with H alone. H equals A times the sine of B. So we can now use our substitution or our transitive property. If H equals B sine A and H equals A sine B, we could say that B sine A equals A sine B, since each of them equal the height, right? And we can now take this equation and we can divide each side by, in this case, we can divide each side by B, and we can divide each side by A, and we end up with this proportion. We have sine A over A, we moved the A under here, right, equals sine of B over B. Isn't that interesting? Sine of B over B equals sine of A over A. We could also use another altitude. We could draw an altitude from, let's say, vertex A to side CB, and we could find that we also could create an equivalent proportion that is sine of C over C. This is the law of sines. So for any triangle ABC, doesn't have to be a right triangle, that has side lengths A, B, and C, sine of A over A equals the same ratio as the sine of B over B, which is also equal to the sine of C over C. And we can use the law of sines to solve a triangle as long as we're given two angle measures in any side, so like ASA or AAS, right? Or two side lengths and a non-included angle measure, so SSA. So in other words, if we're given sides A and B, we would need to know either angle A or angle B. If we're given side lengths A and B and no angle C, we can't solve that triangle. That's C is included. It's between side A and B. Okay? So let's find the measure of FG, side FG here. Okay? Round the lengths to the nearest tenth and the angle measures to the nearest degree. So we know that FG is opposite this angle H, right? So the sine of H over this missing side, let's say call it X, sine of H over X equals the sine of F over 40, right? Using our law of sines. Okay, and now we substitute what we know. We know that F is 39 degrees and GH is 40, right? And we know that H is a 32 degree angle, and now we simply have one unknown, FG. And you can use your calculator for the sine of these angles. We can multiply both sides using our cross products property, and we would now divide both sides by the sine of 39 degrees, right? And we see, we end up with FG being 33 and 7/10. And they ask us to round to the tenth, so it's 7/10. Very good. Isn't that cool? What an awesome ratio, the law of sines, huh? Okay, let's use it now to find a missing measure of an angle, angle Q. Go ahead and set up your law of sines ratio and substitute and come back and check. Okay, so we know that sine of P over QR should equal the sine of Q over PR, right? That's just our law of sines. And so now let's use our substitution. Substitute 51 degrees for the angle P. And we know the sides, QR is 8 and PR is 6. It's just substitution. And now we're going to isolate sine of Q just by multiplying both sides by 6, right? And sine of Q equals 6 times the sine of 51 degrees over 8. And round your answer to the nearest degree, and you should have a 36 degree angle. It's important that we use the inverse sine function because a sine of Q equals this ratio, and so we need to find the measure of Q, which is the inverse sine. So we basically take the inverse sine of both sides, don't we, to find the measure in degrees, okay? Let's find the measure of NP. Okay, go ahead and come back and check your work. Once again, set up your ratios. We have angle N, so sine of N over MP equals a sine of M over NP, right? And substitute known values. And to isolate, we can use our cross products and then divide, right? Cross products and divide. And we have NP. This should not say degrees, right? We just found a length, NP, so ignore the degrees. If we're going to round the length to the nearest tenth, it looks like 34.9. And I don't know what the units are. We could just put U for units. Find measure of angle L to the nearest degree. Make sure you do it before you check our work here. So we have a known angle K, so sine of K over JL equals sine of L over JK. That's our law of sines. And substitute known values, and now we need to isolate the sign of L, so let's multiply both sides by 6, right? Oh, now they're going to have to divide by 10, the way they did it here, right? And then we have sine of L equals 6 sine of 125 over 10, so we're going to take the inverse sine of that ratio, and we have 29 degrees. And let's find the measure of angle X. Okay, set up your ratio. Sine X over YZ equals the sine of Y over XZ. And let's substitute our known values. And now we simply multiply both sides by 4.3, and then we'll take the inverse sine, right? And there you go. And we should have a 26-degree angle. Good. One last try. Find the measure of AC. Come back and check your work. You know, I think really they're asking you here to find all measures. And so why don't you make sure you solve the entire triangle. So the first thing you could do is just solve for this unknown angle, since we know two angles, right? And that angle is 180 minus 67 minus 44, right? So we have angle A is a 69-degree angle. And now we can use our ratios to find the two unknown sides. So go ahead and find the unknown sides. In this case, we're going to find AC. We know BC, and we have all the angle measures, right? And so we simply substitute and solve for AC. And AC equals 17.7, right? And now we have 17.7, 18, and again, we could use our law of sines to find AB. And they end up not finding it here. So if you did, good for you. The law of sines cannot be used to solve every triangle. If you know two side lengths and the included angle measure, or if you know all three side lengths, you cannot use the law of sines. Instead, you can apply the law of cosines. Looks a little more complex, but it's a very useful method for solving any triangle. So for any triangle, A, B, C, with side lengths of A, B, and C, A squared equals B squared plus C squared minus 2B times C cosine of A. So you see where it gets the name cosine, right? So for any unknown side, we simply allow the square of that side to equal the other two known sides, the sum of the other two known sides, right? So if we don't know C, we can say C squared would equal the other known sides, A squared plus B squared, minus 2 times AB times cosine of C. So this is something we just simply have to memorize right now, and then I think we walk through a proof for this in your assignment. You can use the law of cosines to solve a triangle if, again, you are given two side lengths and the included angle measure, SAS, or three side lengths, SSS. And the angle referenced in the law of cosines is across the equal sign from its corresponding side. So in other words, if I'm looking for the unknown side A, then notice that we're using cosine of A. If I'm looking for the unknown side B, then on the left side I've got B squared, and way over here I've got the cosine of B. C squared, so I'm using the cosine of C. Okay, so it's pretty logical. It's not too hard once you start using it to remember this rule. So let's find the measure, and we're looking for XZ. Round your length to the nearest tenth. All right, we're finding XZ, so we would say XZ squared, this unknown side squared, equals XY squared plus YZ squared, these two sides, minus 2 times XY times YZ times the cosine of Y. There's our law of sines. let's now substitute the known values. XY is 35 and YZ is 30. We know our angle measure is 110. Okay, be sure you're using your correct order of operations, right? And when we simplify, we end up with XZ squared equaling this huge number. So what must we do? That's right, take the square root, and we get 53.3. Okay, let's find the measure of T. So look at this, we don't have a single angle. And so we're trying to find the measure of angle T. So this is the side opposite that, right? So we would go ahead and say RS squared equals RT squared plus ST squared minus 2 times RT times ST times a cosine T. So we had to set RS squared on one side of the equation because it's opposite the angle we're finding, T. And now we substitute. And now we can start to solve for the cosine T, right? And so we find these values. And now let's subtract the 290. And we'll divide by negative 286, right? And, whoops. Okay, so we need to divide by the negative 286, right? And now we are trying to find the measure of the angle, so we're going to have to use the inverse cosine, right? And we find that the angle measure is 33 degrees, rounded to the nearest degree. Don't forget, do not round your answers until the final step of a computation. If a problem has multiple steps, just store the calculated answers to each part in your calculator. Okay, just keep it as long a number as possible, round at the very end. And there you go. Good job.